Assalamu alaikum. My name is Sushma Karmakar. Today I will talk about Caesar cipher algorithm. Let's get started. First of all, we have some introduction. The explanation of Caesar cipher algorithm. Caesar cipher shifts each letter a fixed number of positions down the alphabet. Imagine rolling an alphabet wheel that many positions, replacing each letter with the new one it lands on. For example, with a shift of 3, A becomes T. Suppose I consider A as 1, then B becomes E, and so on. Warping back to the beginning, if it goes past Z. Why Caesar cipher algorithm needed? Educational. It's a beginner-friendly introduction to cryptography, teaching core concepts like substitution and key-based encryption. Symbolic or recreational, it can be used for basic secret messages or puzzles to its easy decoding, adding a playful layer to communication. Let's move on to the next page. Here, I will explain you the Caesar cipher algorithm mathematical term. So I consider uh, plain text as my name, Sushma Kormakar, and the key is 762, which is my student ID. So now we will convert plain text into cipher text. So how can we do that? Let's see. First, we have P, which means plain text, and we wrote SUSMOYKOR all of this here. Then we have PI. PI means the number of alphabet. So if S equal to 19, U equal to 21, S equal to 19, I consider A as 1, B as 2, C as 2 like this. Then the key is same everywhere, which is 762. You can see that. After that, we have CI. CI means the code of ciphertext or the number of ciphertext. The rules is we need to convert into sum pi plus k. So pi plus k means 19 plus 762, which is 781, and again 21 plus 762, which is 783, and 762 plus 19, 781, like this. But we can see that here every ci number is more than 26. So where we can find the alphabet 781, we have no alphabet, the list of 781. So we need a logic here. So where's the logic? Logic is we need to consider as position and shift key like this here. After that, we need to modulus 26. Position plus shift key, we got the value, then value modulus 26, then we found another value, which is our the main value of ci. So here we got 1, we got 3. This all are 781 modulus 26, then we got 1, then 783 modulus 26, we got 3, like this. So here you can see that all the value are under 26, 1 to 26. So it's easy for us. Then we will consider 1. 1 means A. Firstly we said that. Then 3. 3 means C. 1 means A. 21 means U. 23 means W. 7 means G. 19 means S. 23 means W. 26 means Z, which is the last alphabet. 21 means U. 23 means W. 19 means S. 13 means M. 26 means Z. So for the plain text of my name, we get the ciphertext, which is A C A U W G S W Z U WSMZ, and we call it as a encryption. So let's move on to the next page. Here we got the decryption. What the description means. Here we got the value of ciphertext. In decryption, we work with this ciphertext and got the same value as plain text. So let's see Here I write all the ciphertext here, which is C. Then I write the number of the alphabet here: 1, 3, 1, 21, 23, 7, 19, 26, 21, 23, 19, 13, 26, like this. Then the key is same. Here also same: 762, 762, 762. All of this. Then here the law is, when we found or find out the plain text, we need to, the rules is position minus shift key. That means ci minus k. But encryption we have pi plus k. But here in decryption we need to ci minus k. So 1 minus 762, which is minus 761. Then 3 minus 762, which is minus 759. Like this, all of we got the every value. Then here we have another problem, like encryption. We have no value. We have no value. Sorry, we have no alphabet in minus 761. We need to find out the value within 1 to 26. So how can we find out? Let's say here we need to first of all position minus shift key. That means 1 minus 762. Then also we need to modulus 26. So in encryption we need to do plus or sum, and in decryption we need to do minus. That means the subtraction. Then so after this we will get the value of 19, then 21, in 19, 13, 15, 25, 11, 15, all of this. So you can see that we got the value S U S M O Y K O R M O K R, which is same as the plain text. So it's the correct way to do this. After that, I will write the code of the zero cipher algorithm. Here you can see some picture of my code and output. So how can I do this code? I will explain you. So now I go to a IDE, which is called PyCharm. So now I will explain about code. First of all, I give a variable n equal to false. It's nothing, but it's needed for running this code. Then I write while not end. So I I write a while loop for how much time I want to do this encryption or decryption. That's why. So first of all, when int equal to false, I give while not equal to. That means while not means int means false, but for the not we get the true value. Then the loop will running. That means the condition is true. Then I for first of all, what we want to do encryption or decryption. So I get a input. Oh, I wrote this code in Python. So what to do? I take input, type encrypt for encryption, type decrypt for decryption. So then I wrote another text variable, and here I should type one message. That means which message I want to. That means the plain text. Then I consider as a variable shift, which is work as my key value. Then enter the shift key. Then I give a combination if what to do equal to encrypt. That means I want encryption. Then when we type in encryption, the condition is this condition. If condition is true, then it is move on to the encryption function. Here I write the encryption function. This is the main part. I will explain you later. First of all, understand this. Then we have elif. Elif means else if function. In Python, elif means else if. What to do? Call decrypt. Suppose we want decrypt, so we'll write here in decrypt. So we'll get the decrypt. that way. After that, we if we want to play again means if we, why we give this while loop. Here is the reason. If we want to continue this process, then we'll tap yes. If we tap yes, then it is same at easy. So int equal to false, and the loop is running. After that, if we want no, that means we don't want it anymore. So it is become false. Up, sorry, it becomes true, and it is move on to the false function. Move on to the false function, and it become true function, and it become the false. Then the loop will be stopped. So suppose in I type encrypt. So first of all, we need the encrypts. So here in encrypt, the if this if condition will be true, then it is called the encryption function. Here I give this text as a plain text here, and shift is equal to shift key. That means here text means or plain text means Sushma Kormakar as we seen in the algorithm, and shift key is equal to 762. So suppose I write encrypt, so we want encryption. So let's move on to the encryption function. So here we have alphabet. I write all of alphabet A to Z here. Oh, see, I had all of alphabet in lowercase, so I lowercase. But if we write the um, larger alphabet, there will be not create a problem because I wrote dot lower here. It will convert into the lowercase. If we write in uppercase, then it convert into the lowercase. So after that we have plain text and shape. We have plain text means I write Sushma Karmakar here, so it is move on to here, and shift is 762, it is here. Then cipher text. What we need? We need cipher text. So first of all, we don't do anything. So the cipher text is null here. After that, we get a for loop character in plain text. That means character is a variable here in plain text. That means I give the plain text Sushma Karmakar. It will run. Run uh, the full Sushma Kormakar S U, first of all S, then U, then S M, like this. Then if character in character in alphabet means if which character or the sentences I write, if like S is in alphabet, yes, S is in this alphabet, then we will work like this. If the alphabet like I give 1, 2 or something like this, it is not in the character, then it is move on to the else part. Else part means it's just simply added to the cipher text, nothing else. Then we have for loop. Then we have position. I wrote variable as a position and alphabet dot index here. So first of all, here I write was Sushma Karmakar. So first of all, the character is S here. So we get the value of index S. Then what was our law or logic? New position equal to position plus shift key modulus 26. That means 26. So position is 19s and shift key is 7x to 781, and get the modulus. We get the variable. So here I can see 1. So we get 1 here. Then the alphabet position and new position index and alphabet convert into the ciphertext. That means A converted to here, and like this all of these are working. After that we just simply print. Here is the text of encryption is ciphertext like this. Then we have the decryption part. It is also like same but some different. So I can see you. Suppose I write here decrypt. I need to decrypt here. So it also get what here will convert into ciphertext, because we need ciphertext to plain key. In encryption, what we do? Plain text to ciphertext. Or here we need ciphertext to plain text. So we send the ciphertext, and the key is always same. Key here, and it's move on to the decrypt functions. We got ciphertext here and shift key here. After that, the plain text is null. First of all, we didn't do anything. Then we have 4 character in ciphertext. How much length in ciphertext? The for loop is running to this length. And after that, if character in alphabet like this, we as we say in encryption, if the character is in the this will work the next step, the if step. But if the character is not in alphabet list, then it will simply add into the plain text or nothing else. So after that, we get the index of the first alphabet of position. Then we get the new position. New position here. The in encryption, what was position plus shift key modulus surface. But here the logic is position minus shift key modulus 26. So we get the value here, and after that, the value is plain text as new position index got into alphabet, and we got the plain text as it is. So at this logic, I wrote this code. If I run this code, you can see I can show you that at first, suppose I want encrypt, encrypt, type your message. What was my message? My name is Rusman. Okay. Shift key was 762. As you see, as you seen that the text after encryption is like this. Uh, Here I show you the encryption. Yes, I want to continue. So I will type yes. Then I want what? Decryption. Decrypt. Sorry, decrypt. Type your message. So as I copy it, shift key as same 762. Yes, you can see that here my name is Sushma. First of all, my plain text was my name is Sushma, and we got this ciphertext value. After that, um, we sent this ciphertext value, and key was same, and we got back our plain text. So here, no, I don't want to continue. I show you all of the content of this code. No, and here we have thank you, goodbye. Thank you for watching. That's all for me. Here you can see all of the content. Here the code, the output, everything. That's all for me. Thank you so much.